In this video, we are going to look at factorization. Now, there are different methods to factorize. There's the basic one, there's the factorization by grouping, there's the factorization of the trinomial, and also there's difference of two squares. So let's start with the first type. So here I have to factorize this expression 3x plus 3y. Now here I have two terms, and terms are separated by plus or minus signs. Okay, so the 3x is one term and the 3y is another term. So the main thing here is to look at your terms, no matter how much terms you have, and see what is the highest thing that can go into all your terms. Now in this question, it's obvious that 3 could go into 3x and 3 could go into 3y, and 3 is the highest thing that can go into the two terms. Now you don't want the lowest thing because 1 can go into any number. So 1 could go into 3x and 1 could go into 3y. So, 1 will be the lowest thing that could go into all the terms. So you don't want the lowest, you want the highest. Alright, so I'm going to put the 3 because that's the highest thing that could go into all my terms. I'm going to open my brackets and then I'm going to say, okay, 3x divided by 3, that will give you x. And then I'm going to have this 3y divided by 3, well, positive 3y divided by 3, which is positive y. Alright, and that's the answer there. Now, a point to note is that factorization is the opposite of expansion. So in expansion, you would have multiply to get rid of these brackets. And in factorization, we are dividing to get back the brackets. Now let's look at a second question here. Now in this question, I have three terms, 5a, 10b, and 15c. Alright, now again, I'm looking for the highest thing that can go into all the terms. So it's obvious that 5 could go into 5a, 5 could go into 10b, and 5 could go into 15c, and 5 is the highest thing that can go into all three terms. So I'm going to put my 5, I'm going to open brackets, and then I'm going to say that 5a divided by 5, which is a. This is positive 10b divided by 5, which will give you a positive 2b. And then I'll have negative 15c divided by 5, which is negative 3c. And that's my answer. Now let's look at the third question here. Let's deal with the symbols. So I have a squared take away a cubed plus a to the power 5. I'm going to factorize. Now I'm going to ask myself, what is the highest thing that could go into all three terms? Now some people want to say that's a because a could go into all three terms. That's true. But a is not the highest thing that could go into all three terms. Let's start with the wrong thing. Let's say I choose to say that a to the power 5 is my highest common factor. Well, a to the power 5 cannot go into a squared because a to the power 5 is bigger than a squared. Likewise, it can't go into a cubed because a to the power 5 is bigger than a cube. So I can't use a to the power 5. What a to the power 3? Well, a to the power 3 could go into a to the power 5, so that would work. But a to the power 3 cannot go into a squared, so that's why I can't use it. So a squared could go into a squared could go into a cube, and a squared could go into a to the power 5. So a squared is the highest thing that can go into all my terms. So what I like to say is that when you're dealing with the symbols, choose the one with the lower power. That will be a HCF, and HCF is the highest common factor. So out here I'm going to put my HCF, my highest common factor, which is a squared. I'm going to open brackets, and then I'm going to say, okay, a squared divided by a squared, which will be 1. Alright. A cube divided with a squared. Now remember, we're dividing, right? So laws are indices, we subtract the powers. 3 take away 2, which is 1, so you're going to get a to the power 1. And of course, this is negative a cubed, so when I divide with positive a squared, I am going to get negative a to the power 1, which is just a. Alright, coming across here now, we have positive a to the power 5 divided with a squared again. The bases are the same, being a. Laws are indices, we divide in, subtract the two powers. 5 take away 2, which is 3, so I'm going to get positive a cubed. So I'm going to get positive a cubed. Alright, and that's the answer there. Let's try another one. Alright, so here I have to factorize x cubed y to the power 5, take away x squared y to the power 7. Now again, with the symbols, as I said, look for the one with the lower power. So with the x's, you have x cubed and x squared. I'll choose x squared. So I write x squared. Alright, for y to the power 5 and y to the power 7, I'll use the y to the power 5. That's the one with the lower power. So y to the power 5. So this would be my HCF, x squared y to the power 5. So open brackets. Now when I divide x cubed with x squared, I'm dividing, right? So I'm subtracting the powers. So I get x to the power 1, which is just x. And then I'm going to divide y to the power 5 with y to the power 5, which will give you 1. Now, what I'm going to do with that 1 is place it here. And that means x multiplied by 1, which will just give you back x. So therefore, there's no reason to write the 1, right? Because it's just going to give back x. So I'm going to put my takeaway sign. All right. We're going to have x squared into x squared, which is 1. So I can put the 1. Right, and of course that 1 will be multiplied by whatever we get when we divide the y to the power 7 with the y to the power 5. So when we do that, y to the power 7 divided with y to the power 5, subtract the powers, you're going to get 7 take away 5, which is 2. So that's y squared. Now again, because this 1 is being multiplied by y squared, you just get back y squared. There's no reason to write the 1. So it's going to erase the 1. It's going to bring y squared a little closer. Alright, and that's the answer there. Let's do a mixture of numbers and symbols. Alright, so in this question, we have 3 terms, right? Remember, terms are separated by plus or minus signs. Alright, so 1, 2, 3. So I look at all 3 terms. What I like to do is look at the numbers first. See if I can get the highest common factor there. So we have 16, 8, and 4. So the highest common factor would be 4, because 4 could go into 16, 8, and of course 4 could go into 4. So I'll write 4 first. Then I'm looking at the symbols. Now I have m to the power 5, m cubed, and m to the power 10. So m is common to all 3 terms. So I use the one with lower power, which would be m cubed. Alright, so we have m cubed. Now you may want to go and say, okay, let's put the n here, but remember it must be common to all your terms. So yes, there's an n here, but there's no n on this second term or on this third term. So you can't use n in your highest common factor. Alright, so we're going to open brackets. And then we're going to say, alright, 16 divided with 4, which is 4. Alright, then we're going to have the m to the power 5 divided with m to the power 3. Let me make that m to the power 5 better. Alright, so yeah, m to the power 5 divided with m to the power 3. Take away the powers, 5 take away 3, which is 2. So you're going to get m to the power 2. And obviously, there's nothing to divide with the n to the power 4, so we're just going to bring it back. So it's going to write back n to the power 4. Alright, so now we're going to say, okay, 4 into positive 8, or positive 8 divided with 4, and you're going to get 2, so positive 2. And then we're going to say, okay, m cubed into m cubed, that will be 1. Alright, and as you know, if you write the 1, it's just 2 multiplied, well, it's just the 1 multiplied by 2, which is just 2. So you don't need to write the 1. Alright, then we come in here now. 4 into negative 4, which is negative 1, or you could say negative 4 divided by 4, which is negative 1. So I'll put the negative sign and I'll hold off on writing the 1, because we know if you multiply anything by the 1, you're just going to get back the same thing. Alright, and then I will say, okay, m cubed into m to the power 10, subtract the 2 powers, 10 take away 3, which is 7. So we're going to get m to the power 7. Close brackets. And that's the answer there. Alright, so this is the last one we'll do on this type. So here we have 7p squared q plus 3pq. Now, when I look at the numbers first, I see 7 and 3. Obviously, there's nothing, I wouldn't say nothing here, because 1 could always go into any number. Alright, so there's nothing higher than 1 that could go into both 7 and 3. So I have no choice but to use 1. Alright, now I'll hold off on writing the 1. Let's see if we get anything else. Alright, so with the numbers, right, it's just 1. Now let's look at the symbols. So we have p squared and p, and as I said, we use the one with the lower power, so we'll be using p. I have q to the power 3 and q, so again we use the one with lower power, which is just q. So my HCF, highest common factor, is just pq. Open brackets. I'm going to divide this 7p squared q cubed by pq. So obviously there's, well, there would be a 1 out here, right? So 1 into 7, 7, right? So you could say it like that, or you could just say, okay, there's nothing to go with the 7, so you're just going to write it back. And then we're going to have, well, p into p squared. again, subtract the powers. 2 take away 1 is just 1, so it's going to get p to the power 1. So that's just p. And same thing here, q into q to the power 3. 3 take away 1, because q is q to the power 1, right? So 3 take away 1 is 2, so q into q cubed is q squared. So it's going to write q squared. Plus, then we're going to have, well, nothing to go to 3, so we're going to get back to 3. And then we're going to say, okay, well, PQ into PQ, same thing divided by the same thing, you're just going to get 1. All right, so if you write it 1 times 3 is 3, so there's no need to write it. All right, so close the brackets, and that's the answer. Now, I said this would be the last one, but let me do one more with a negative sign on the first term. All right, so let's look at this last one for this type here. So we have factorized and I have negative 25x to the power 3 plus 15x squared. Now, when you have actually, I should put it like this. Whatever sign is in front of the first term that you have, your HCF going to take that sign. All right, so because this first term is negative, my highest common factor would be negative. All right, so I look to see what's common between these two terms. I have 25 and I have 15. So 5 is the highest thing that can go into both of them. All right, so remember my first term is negative, so my HCF will have to be negative. So I'm going to have negative 5. Let's look at these symbols now. X cubed, x squared, using one of the lower power, so using x squared. All right, so I'm going to write x squared. Then I'm going to open brackets. So now I'm going to say negative 25 divided by negative 5. I'm dividing two negative numbers, so I'm going to get a positive number, right? So 5 into 25 is 5, and it's going to be positive 5. All right, then I'm going to say, okay, the x squared into x cubed. All right, subtract those powers, get x to the power 1. So that's just x. Then I'm going to say, okay, positive. See, sign from the 15 is positive. So positive 15 divided with negative 5. I am going to get negative 3. All right, so negative 3. And of course, the x squared divided with x squared is 1. If you place the 1 here, you're going to have 1 by 3, which is just 3. So you don't need to write it. So I close my brackets, and that's the answer. So now I'm going to look at a different type of factorization, which is called factorization by grouping. Now, here we have 4 terms, right? Remember, terms are separated by plus or minus signs. So I have 1, 2, 3, 4. 4 terms. Now, the same technique from the first type still applies. I still have to look at all my terms and determine if there's anything that can go into all 4 terms. All right, anything except 1, I should say. All right, so when we look at this, so when we look at all 4 terms here, there's nothing that could go into all 4 terms except 1. All right, so whenever you have 4 terms and there's nothing that can go into all 4 terms except 1, you have to look at the possibility that, you know, maybe it's a factorization by grouping question. Okay, so now what we're going to do is look at 2 terms at a time. So I'm going to look at these 2 terms and I'm going to use the method I was using before, which is, what's the highest thing that can go into both terms? Now I have 3m squared and 3mn. So I'm seeing that 3 is common to both terms, so 3 will work. Also m squared and m, so I'll use m. So for my highest common factor, I have 3m, open brackets. All right, now I'm going to divide 3m squared to 3m, so 3 cancel 3, and m into m squared is m. Then I'm going to have 3m into negative 3mn. So again, 3 cancels the 3. All right, m cancels m, and I remain with n. Now remember, we are dividing a negative with a positive, so we're going to get a negative answer. So negative n. All right, now I'm going to look at the next 2 terms. And I'm going to do the same thing. What's the highest thing that could go into both terms? I'm seeing 2 is common to both. And then I'm seeing n and n squared, so I'll use n. So 2n would be my HCF. And the first term is positive, so my HCF would be positive. So I'm going to put positive 2n, open brackets. So now I'm saying, okay, 2mn divided with positive 2n, the 2 cancel 2, n cancel n, I remain with m. Then I'm going to say, okay, negative 2n squared divided with positive 2n. I'm dividing a negative with a positive, so my answer will be negative. All right, so 2 cancels 2. N into n squared is n, so I'm going to have negative n. Close brackets. Now, what we're going to do here is we're going to look at the terms on the outside, this 3m and this positive 2n, and we're going to put that in brackets. So I'm going to write 3m plus 2n. Right, put that in brackets. Then I'm going to look at the brackets, which is m take away n and m take away n. Now notice, these two brackets, they are the same. If you do a factorization by grouping question and you don't get these two brackets being the same, then you do something wrong and you need to check over your work. Alright, so I'm going to take what's in these two brackets and just write it once. So I'm going to have m take away n. And that's the answer there. Alright, so here we have our second question for factorization by grouping. And as I said, the only time you do factorization by grouping is when you have 4 terms and there's nothing except one that's common to all 4 terms. So when I look at this question, I have 4 terms, 1, 2, 3, 4. But I'm seeing 4, 4, 2, 2. Then that tells me that 2 could go into all 4 terms, right? So 2 will be the highest thing that can go into all 4 terms. So that first technique still applies. So I have to go through and divide all 4 terms by 2. So I'm going to say 2, open brackets, and then I'm going to say, okay, 4x squared divided with 2 and get 2x squared. Then I'm going to say, okay, 4xy divided with 2, and I'm going to get positive 2xy. Then I'm going to say negative 2xy divided with 2, which will just give negative xy. And then I'm going to say negative 2y squared divided with 2, which will just give negative y squared. Close brackets. Now you might think, we're done. We factorized, right? But we didn't factorize completely, because after you did this, yes, you factorize, but inside this brackets, we have 4 terms. And we need to check if we could factorize by grouping. All right, so I'm going to look at the first 2. So we're just checking. Now, you could have 4 terms and then you can't factorize by grouping, and this would be the answer. All right, but you still need to check. Anytime you have 4 terms and you have to factorize, you need to check if you could factorize by grouping. So we're going to check now. So I'm going to look at the first 2 and ask myself, do I have anything common between the first 2? And I'm seeing 2 and I'm seeing x squared and x. So that tells me 2x is common between the first 2 terms, and 2x is the highest thing that could go into both of them. So I'm going to write this 2 out here, open brackets. But for these 2, I'm going to write the 2, all right, and the x, because the 2x is common to these 2 terms. All right, and then I'm going to open brackets again and say, okay, 2x squared divided with this 2x, so 2 cancels 2, x into x squared is x. So you're going to get x here. Then you're going to say 2xy divided with 2x, so 2x cancels this 2x, and you remove positive y. So positive y, close brackets. Then I'm going to look at the next 2 terms here and decide, is there anything common between those 2 terms? Now I'm seeing xy and y squared, so y is common to both terms. Y will be the highest thing that can go into both terms. And the first term in this factorization here is negative. So my HCF would be negative. So I'm going to write negative y. Open brackets. Then I'm going to divide this negative xy with this negative y. So I'm dividing 2 negatives, so I'm going to get a positive. So y will cancel y and remain with x, and that'll be positive x. Then I'm going to divide this negative y squared with this negative y. Again, we're dividing 2 negatives, so we're going to get a positive answer. So if you want, you can write the positive sign one time, right? You're going to get a positive answer. And now we're going to have y squared divided with y, and that'll just give you y to the power 1, which is just y. Close brackets. So again, we notice that these 2 brackets are the same. So yes, these 4 terms could be factorized by grouping. Now I'm going to just put this brackets at the end here to close off this brackets that we started here. So I'm going to take these 2 terms outside the brackets, the 2x and the negative y. But first, I'll write it 2, open brackets like that. And then I'm going to take these two terms, the 2x and the negative y, and put it in brackets. So I'm going to have 2x, take away y, close brackets. And then these two brackets that are the same, I'm going to write it once. So I'm going to have x plus y. And then I'm going to close off this brackets here. I'm closing off this brackets because I opened this one here, because the 2 is outside. Alright, so now this is the answer. Now we know in mathematics that, if you have something in brackets next to another thing in brackets, multiplication is understood. So this means that this 2x take away this y is being multiplied by this x plus y. Now having this 2 on the outside here with this brackets means multiplication is understood. So this 2 will be multiplied by this 2x take away y. So if we write it with all the brackets being 2, open brackets, the 2x take away y like this, and the x plus y, it still means that this 2 is being multiplied by this 2x take away y. So there's no need for this brackets on the outside here in your final answer. These two things mean the same thing. Alright, so my third question here for factorization by grouping is a bit of a trick question, because some students just think that, you gotta go and expand these brackets and then factorize. But the point to note here is that you see that these two brackets are the same. Alright, so all you have to do is just take what's outside the brackets, meaning the 3xy and this negative 4, and put that in brackets. So that's going to have the 3xy take away 4. And then I can write this m take away k. That's occurring twice. Just write it once in brackets. So I'm going to have m take away k. And that's the answer. As simple as that. Okay, so now we're going to move on to the technique using difference of two squares. Alright, so first let's write out the formula. So what you're supposed to know is that if you have a squared take away b squared, the answer would be a plus b times a take away b. Now it doesn't matter if you write the a take away b first and then the a plus b. That's quite okay. Alright, so notice difference would mean to subtract, so that's why we have the subtraction sign here. And two squares mean we have two square numbers. Now notice we have a squared here, but in the brackets we have a, right? And we have b squared here, and in the brackets we have b. So let's see what our question would look like. Alright, so we have x squared take away 36. Now you might ask, well, how to factorize this? There's nothing common. Remember, the first method that we did, those principles still apply. You still have to look to see if there's anything common between the two terms, except one. Alright? So, there's nothing that could go into both terms except one, so that first method is out. Alright? So, we apply the difference of two squares here. We have a subtraction sign. Now, if this was a plus sign, this method would not work. Only works when we have the subtraction sign. Now, we have x squared, so that's a square number because x squared. And we have 36. And you're supposed to know that 36 is 6 squared. Alright, so this is x squared take away 6 squared. So now we have the difference, subtraction of two squares, x squared and 6 squared. So the answer would be, write it in brackets like this, with all the squares, one is plus, one is negative. If a comes first and then b, in your brackets you have a, then b. So here we have x first, then 6. So in the brackets we're going to have x, then 6. Alright, 1 plus, 1 negative. Alright, so my answer would be x plus 6 and times x take away 6. And that's the answer, as simple as that. Now I said there's no problem if you want to write the x take away 6 first and then the x plus 6. That could work too. Let me write it out. So no problem, this is the answer, x take away 6 times x plus 6. No problem writing it like that. Now, this is an interesting question because some people like to look at this and, well, some students like to look at this and say, well, well, this is not a difference of two squares because, yeah, you had w squared here, but 1, what squared is 1? Alright? Well, you could write 1 as a square number because 1 squared means 1 by 1, which is still 1. Alright, so this could be written as w squared take away 1 squared, because 1 squared is 1. And now you have what? The difference, subtraction of two square numbers. And square numbers are what? You have w squared and 1 squared. So w and 1. So in my brackets, I'm just going to use the w and 1. W comes first, then 1. All right. As long as you have 1 plus and 1 minus, you're good to go. That's the answer. Now, let's look at this third question. Now, we need to be reminded that this square is only on the m, not the 49. And the square is only on the n and not the 16. Now, if I wanted to write the square on both the 49 and the m, I'll put 49m brackets squared. And now this would have mean that the square has to go on both the m and the 49. All right, but that's not the case here. All right, so I'm going to take that off. So all we have is the m squared and the n squared. But then I would recognize that 49 is 7 squared and 16 is 4 squared. So if I was to write that out as 7 squared m squared, because 7 squared is 49, take away 4 squared n squared, because 4 squared is 16. So I'm going to shade that, make it more visible. So the 49 is the same as the 7 squared, and the 16 is the same as the 4 squared. Now, as I said, here we have the square on both the 7 and the m, so I can write that as 7m brackets squared. And have the square both on the 4 and the n, so I can write that as 4n in brackets squared. So now this means that the square is both on the m and the 7. Same thing here, square is both on the n and the 4. So now we have subtraction sign, so difference of two square numbers. So that's be 7m and 4n. So in my brackets, that's what I'm putting, 7m first and then the 4n. 1 plus, 1 negative. All right, so 7m plus 4n, brackets, 7m take away 4n, close brackets. Now let's look at our final question for this difference of two squares. You have to factorize 5x squared take away 20. Now you're going to say, well, hey, this is another difference of two squares. But 5 is not a square number and 20 is not a square number. You always have to apply the first principle, which is you always have to look at your terms and see if there's anything common between how much of a terms you have. All right, so we have two terms here, and 5 can go into 5x squared and 5 can go into 20. So 5 is common to both terms, so we have to factorize with the first method. So 5 open brackets, we're going to have 5x squared divided by 5. So that's going to give you x squared. Then we have negative 20 divided with 5, which would be negative 4. Now, yes, we partially factorize, but we haven't factorized completely because within the brackets, I recognize I have two terms, a subtraction sign. This is a square number, and 4 would be 2 squared. All right, so that would be 5 open brackets x squared take away 2 squared, because that's what 4 is, right? 2 squared. So then I'm going to say, well, okay, I have the difference of two squares within the brackets. So now I have to apply that rule, right? So I'm going to write two set of brackets with x and 2, one with plus and one with negative. So I'm going to have 5 open brackets x plus 2 and x take away 2. All right, and that would be your answer. Now you're probably wondering, where did this brackets go? Yes, I can write the brackets around it like that, but as we discussed earlier on, you know, it will mean the same thing as this. All right, so here we're going on to the factorization of a quadratic. So that would be the factorization of the trinomial. All right, so here we have 3 terms. All right, now the order of these terms are important. Notice that the x squared first, then the 5x, then the 6. Now, if they had given me, let's say 5x plus x squared plus 6 like this, and say, you know, factorize this, I would have to rearrange things. All right, so I would have to come and put this positive x squared in front of 5. And now, of course, that 5 would be positive, so write the positive sign. And then bring the 6 like that to get back the same x squared plus 5x plus 6. All right, so it must be in that order. Let me erase this. So now, what I can employ here is a simple method, all right? Because the number in front x squared is 1, only because the number in front x squared is 1, we could do this method. So I'll just look at the last term, which is 6, and say, okay, what are the factors of 6? All right, so let's highlight this last term that I'm looking at, positive 6. All right, and I'm going to say, okay, what are the factors of 6? That's 6 by 1 and 3 by 2. Okay, and then I'm going to look at this middle term here, positive 5, right? Okay, forget about the x, right? Let's look at positive 5 and ask which one of these factors would give positive 5. Now, actually, both of them could, right? Because I could write 6 take away 1, which would be 5, all right? And of course, 3 plus 2 is 5. But let's deal with 6 take away 1 first, all right? Now, when I say 6 and negative 1, 6 take away 1 is positive 5. I'm getting this positive 5 here. But if I multiply 6 times negative 1, I would get negative 6. And now that the negative 6 is not equal to this positive 6 that I have here. So that's why the 6 take away 1 would not be the correct thing to use. So this would be the wrong thing. All right, because yes, I'm getting positive 5, but I'm not getting the positive 6. Now let's try the 3 and the 2. So 3 plus 2 is equal to 5. And of course, if I multiply that positive 3 by positive 2, I'm going to get positive 6. So yes, I satisfy both this positive 5 here and also this positive 6 here by using positive 3 and positive 2. So all I have to do now is come up with the brackets like this. So my variable is x because I have x squared and 5x. So that's why I'm going to put x here and here. And now I'm going to say because positive 3 and positive 2 give positive 5, which is here, and positive 3 by positive 2 give positive 6, which is here, I'm going to write positive 3 and positive 2. And that will be your answer. Now, if I were to put a negative sign in front of the x squared, so it's the same question, but there's a negative sign in front of the x squared, I cannot use this short method here. All right, because this only works when there's a positive 1 in front of the x squared. So if I put a 2 in front of the x squared, this method falls apart and you can't use it. Again, likewise, if I put a negative sign in front of the x squared, this method falls apart and you can't use it. So what we're going to do? Well, I'll use something called product, sum, and factor. So my product is obtained by multiplying the first term by last term, and again it must be arranged where the x squared comes first, then your term in x, and then a constant. Alright, so I'm going to multiply my first term by my last term. Alright, so that will be negative x squared with positive 6, so I'm going to get negative 6x squared. Alright, my sum is going to be that middle term there, the positive 5x. So I'm going to write positive 5x. So now I'm going to be finding the factors of the product. So I'll just forget about the negative sign for now and just focus on finding the factors of positive 6. All right. So we're going to have 6 by 1 and 3 by 2. Now, let's look at the 6 and 1 and 3 by 2 again. So now both 6 and 1 and 3 and 2 could give 5. Forget about the x for now. Let's focus on the 5. All right. So what we want to do is when we add or subtract, we want to get 5. And when we multiply, we want to get a negative 6. All right. So sort of, well, basically same thing we did here. All right. So if we take the 3 plus 2, we're going to get positive 5. And if we multiply the positive 3 by positive 2, we're going to get positive 6. So by using the positive 3 and the positive 2, I'm getting positive 5, which is here. But I'm not getting the negative 6 as here. So you're no longer looking at the 6 here. All right, you're looking at the product, which is negative 6. So I need to get a negative 6 when I multiply. So that's why the 3 and the positive 3 and the positive 2 is wrong. All right, so let's check the 6 and 1. All right, so we're going to have 6 take away 1, which is positive 5. And then we're going to have 6 multiplied by negative 1, which is negative 6. So you can see here that, yes, we get the positive 5 that's here, and when we multiply, we get the negative 6 that is here. So for my factors, I'm going to write positive 6, which is, I'm going to use positive 6x, and negative 1, so negative 1x. Now notice, see, 6x take away 1x is positive 5x, and 6x multiplied by negative 1x is negative 6x squared. So what I'm going to do is have this negative x squared, and instead of writing the 5x, positive 5x, I'm going to replace it with the positive 6x take away 1x, because that is the 5x plus 6. Alright, so you see this come down, this positive 6 come down like this, and I replace the positive 5x with 6x take away 1x. And now we're going to factorize by grouping. So I'm going to look at the first two terms. So my first term is negative, so my HCF would be negative. So I'm going to put my negative sign. And then I'm going to say, okay, what's common between these two terms? Or what's the highest thing that can go into these two terms here? So I have x squared and 6x. So x is common to the two terms. So x would be the highest thing that could go into both terms. So I'm going to write x, open brackets. And now I'm dividing this negative x squared with this negative x. Divide two negatives, you're going to get a positive. And x into x squared is x. So that's positive x. And then I'm going to divide this positive 6x with this negative x. I'm dividing a positive with a negative, so my answer will be negative. So I can put a negative sign here. And then I'm going to say, okay, x into 6x, which would be 6. Then I'm going to look at my next two terms. And my first term for my factorization is negative, so my HCF would be negative. So I'm going to write my negative sign. Then I'm going to say what's common between these two terms. Now, I can't find anything common except 1. So I'm going to write the 1. So 1, open brackets. So now I'm dividing these two terms by negative 1. So negative 1x divided with negative 1 will just give you positive x. And then we'll say, okay, positive 6 divided with negative 1 would give negative 6. Now again, you notice that these two brackets are the same, so we know we're on the right track. So you're just going to take what's outside the brackets here, this negative x and this negative 1, and put that in our brackets by itself. So I'm going to have negative x take away 1. And then I'm going to write this x take away 6 that's occurring twice here. Write it once in brackets. So I'm going to have x take away 6. Alright, so let's look at this last one here for the factorization of the trinomial. Alright, so we have 2x squared take away 5x take away 12. So again, there's a 2 in front of the x squared, so I cannot use that short method. Have to use the product sum factor method. Alright, so I can write p, s, and f for product sum factor. Alright, so again, I'm multiplying the first term by the last term. So that's the 2x squared by the 12. Well, that's the 2x squared by the negative 12. So that'll give you negative 24x squared. Alright, so negative 24x squared. And then for my sum, I'm going to have the negative 5x. Alright, so negative 5x. Negative 5x. That's my sum. So notice I'm not looking at the last term to find the factors of the last term. I'm finding the factors of the product. Forget about the x squared, forget about the negative sign. You want factors of 24. Alright, so I'm going to write out, okay, 24 by 1 is 24. 6 by 4 is 24. 8 by 3 is 24. We have 12 by 2 is 24. Okay, now when I'm looking at all these factors here, I'm going to see, that's going to go through which one is going to give me 5 when I add or subtract. Now 24 and 1 can never give you 5. 6 and 4 can never give 5 if you add them or subtract them. 12 and 2 can never give you 5 if you add it or subtract it. But 8 and 3, 8 take away 3 is 5. Alright? So that's why I'm going to use 8 and 3, because 8 take away 3 is 5. Now I still need to check to make sure everything's lining up. Now remember, we're trying to get negative 5. So I'm going to use the 8 and 3 as 3 take away 8 to give negative 5. All right. Now, I have my negative 5. Let's check the multiplication to make sure everything is lining up. So I'm going to put 3 times negative 8, which is negative 24. So here I have my negative 5 lining up with negative 5 here. And I also have my negative 24 lining up with the negative 24 here. So 3 take away 8 works. All right. So what I'm going to write is 3x take away 8x, right? Because that is equal to negative 5x. And of course, if you multiply 3x times negative 8x, you're going to get negative 24x squared. So I'm going to come here and write 2x squared. And instead of negative 5x, I'm writing positive 3x take away 8x. Now, a point to note, a lot of people like to think that because here's a negative sign, a negative sign is going to come back here. No, that's not true. All right. What's coming here is what we have for the factors here, which is positive 3 and negative 8. Well, positive 3x and negative 8x. So positive 3x and negative 8x, because this would give you negative 5x. And then I write back my negative 12. So now we're going to factorize by grouping. So I look at the first two terms and say, okay, what's common there? All right, well, nothing with the numbers except 1, but I have x squared and x. So x is my HCF. So x, open brackets, divide 2x squared with x, and we get 2x. All right, divide 3x with x, well, positive 3x with x, you get positive 3, close brackets. Then I'm going to look at my next two terms. And because my first term is negative, my HCF would be negative, so I could put a negative sign one time. All right, I have 8x and 12. Well, 4 could go into 8x and 4 could go into 12, and that's the highest thing that could go into both of them. So negative 4 would be my HCF. Open brackets, divide negative 8x with negative 4, and I'm going to get positive 2x. And I'm going to divide negative 12 with negative 4, and I'm going to get positive 3. Again, notice we have our two brackets being the same, so we know we did the right thing. So I'm going to take what's outside brackets, the positive x and the negative 4. And I'm going to put that in brackets, x take away 4. And then I'm going to take what's in the brackets here, this 2x plus 3, and write it once. So I'm going to have 2x plus 3, and that will be my answer. So there you have it. These are the basic things you need to know for factorization. So later on, we'll learn how to factorize a cubic expression and so on. So that's it for this video.